Ready to level up your DevOps skills? Welcome to K4 Coding Academy. Master Kubernetes, Terraform, and AI. Get real-world platform engineering projects. Subscribe now and start mastering your future.
Master Azure with our Terraform series. Learn to manage cloud infrastructure with ease. Provision and scale resources automatically. Automate, secure, and optimize. Deploy with confidence.
Welcome to this explainer. Today we're tackling managing Azure infrastructure using Terraform. In a world where AI is just rapidly accelerating how we write and manage code, the way we handle our cloud environments absolutely has to evolve. So we're going to be your guide today on a journey to scale your Azure infrastructure. We're taking it from, basic manual management all the way to a fully automated zero-trust powerhouse. We're literally taking infrastructure as code from basic principles straight through to enterprise-grade execution. Let's get into it.
Okay, looking at our agenda today, we're taking a crawl, walk, run approach. First up, Terraform versus Azure Bicep, then managing modules and state, automating CI/CD pipelines, testing infrastructure with TerraTest, scaling Azure landing zones, and finally, a quick summary.
Section 1. Terraform versus Azure Bicep. To kick off our crawl phase, we really have to answer a fundamental question. Which tool is actually right for your target cloud environment?
So, the core architectural difference between the two really boils down to where the processing actually happens. Bicep is natively Azure-specific, which means the processing happens over on the Azure side. That gives you some pretty fantastic pre-flight processing capabilities. Terraform, on the flip side, is multi-cloud. The processing is done client-side right within the Terraform client, using its own state file and HashiCorp configuration language, or HCL, to calculate changes before it ever even talks to Azure. Now think of their different approaches to modules and authentication like a quick cheat sheet for your DevOps team. For modules, Bicep basically just strings together other Bicep files, while Terraform packages up whole directories of files. And for authentication, Bicep leans entirely on Azure Resource Manager, or ARM, authorization tokens. Terraform, however, authenticates each API based on provider credentials. So if you're rocking a hybrid or multi-cloud strategy, Terraform letting you use multiple credentials in a single configuration is a massive, massive advantage.
Section 2. Managing modules and state. Assuming we've gone with Terraform for those sweet multi-cloud capabilities, let's nail down the foundational best practices for organizing your code and securely managing your remote state.
Because look, as your infrastructure grows, dumping everything into one giant file is just a recipe for disaster. Separating your modules logically into directories for compute, networking, and storage keeps things clean and readable. Plus, you absolutely must adopt semantic versioning. Think of it like saving a specific, locked blueprint. Pinning your source modules to specific tags, like version 1.0.0, guarantees that surprise upstream changes won't accidentally break your active environments.
And this tight organization feeds directly into remote state management. Your Terraform state file is the absolute source of truth. Honestly, if you lose it, you basically lose the ability to reliably manage your cloud. You should always store this in an Azure storage account. But don't just stop there. You need to build in some serious resiliency. Enable geo-redundancy, turn on soft delete for your blobs, and definitely apply Azure Resource Lock so nobody accidentally deletes the exact file that's holding your entire cloud together.
Section 3. Automating CI/CD pipelines. We're officially entering the walk phase.
Because writing great code is really only half the battle. We have to bring automation into our workflow so we aren't dangerously deploying straight from our laptops. A safe, production-grade deployment pipeline follows a really strict sequence. First up, you run a validation check on a pull request. Then, you run a Terraform plan. And this is super important. You publish that plan as a pipeline artifact. Why? Because you want a rock-solid guarantee that what you just reviewed is exactly what gets applied. Finally, you require a manual approval check before that apply stage ever gets near your production environment.
To keep this whole automated process locked down, how your pipeline authenticates to Azure is a huge deal. It is highly recommended to use Workload Identity Federation, which grants secure, temporary access, instead of passing around long-lived passwords or plaintext credentials. Mix that with least privilege roles, like only granting storage blob data contributor to access the state file, and you are drastically shrinking your attack surface.
Section 4. Testing infrastructure with TerraTest. As we get ready to run, reliability becomes the absolute name of the game.
You've automated your pipeline, sure, but what if the code you just merged has a hidden logical flaw? How do we ensure our infrastructure code actually works before it hits production? It's honestly a terrifying thought to deploy blindly. You wouldn't push application code without unit tests, right? So why in the world would you push infrastructure code without them?
We really need to validate our configurations programmatically.
Enter TerraTest. This is an open-source Go-based testing framework created by gruntwork.io, and it is essentially your ultimate safety net. It allows you to deploy infrastructure, verify its behavior, and run unit and integration tests seamlessly alongside Terraform. You can run it right inside your CI/CD pipelines to catch issues way before they reach production.
Catching issues early, automating validation, multi-cloud support, and having reusable Go tests. By writing these tests in Go, you unlock a massive amount of power. For example, your test script can automatically spin up an Azure storage account in a safe sandbox environment. Use Go's libraries to assert that the deployed properties match your expectations exactly, and then immediately, and most importantly, safely, tear the whole thing down so you aren't stuck paying for unused resources. It is real-world validation, totally automated.
Section 5. Scaling Azure Landing Zones. Finally, we've reached the summit, enterprise-grade scaling.
Once your modules are versioned, your state is completely secure, and your pipelines are fully tested, you're ready to deploy Azure Landing Zones. And Terraform is a super popular choice for enterprises with multi-cloud strategies doing exactly this. Microsoft actively supports this ecosystem by publishing level 100 to 400 modules ranging from basic foundations to super complex enterprise setups directly in the Terraform registry, which means you don't have to reinvent the wheel. You can consume pre-built, best practice topologies right out of the box.
Just think about the massive, intricate scale of a hub-and-spoke Azure Landing Zone architecture. With Terraform, you can seamlessly manage identity subscriptions, management groups, connectivity hubs, and sandbox environments all through unified code. You're effectively orchestrating your entire enterprise footprint from one single source of truth.
But at this scale, security is absolutely paramount. You can actually layer in zero-trust principles, operating on that never trust, always verify mindset, directly in your Terraform variables. For instance, just by flipping a single variable to true, you can enable Defender for DNS to block injection attacks, or wire up Sentinel for full telemetry. And crucially, you can use Terraform's lifecycle guards, like setting prevent destroy equals true, to strictly prevent anyone from accidentally deleting your core identity and network resources.
Section 6. Summary. Let's wrap up this journey from basic concepts to enterprise-grade execution. We have definitely covered a lot of ground today.
By mastering tools like Terraform, Azure DevOps, TerraTest, and Landing Zones, you can eliminate manual bottlenecks and securely scale your cloud environment. To quickly recap, we crawled by establishing strong foundational modules. We walked by automating our deployments and ensuring code quality with TerraTest. And finally, we ran by leveraging Microsoft's official Landing Zone modules, which lets us manage massive, zero-trust architectures without missing a single beat.
So, are you ready to eliminate manual errors and transform your Azure infrastructure into a fully automated, scalable powerhouse? The tools are right there. The blueprints are already written, but the next step is totally up to you. As cloud environments get more complex and AI continues to change how we build code, mastering this is a real game changer. If you found this explainer helpful on your journey to infrastructure as code excellence, please like, share, and subscribe. Let us know in the comments which part of the pipeline you're going to automate first. Until next time, keep building.